Hello and welcome to helpyourmath.com. In this video, we're going to talk about De Morgan's Law of Logic. Hopefully before you've seen this video, you watched the video on equivalent statements because that will really come in handy as we talk about De Morgan's Law. So here's De Morgan's Law. It states that for any statements P and Q, that we have two logically equivalent statements. So again, super important that you know what logically equivalent statements are. One is talking about the negation of a disjunction. So if we have a disjunction P or Q and we want to negate it, that's the equivalent of saying not P and not Q. Notice that the disjunction turned into a conjunction when we negated it. So it becomes a conjunction here. And this one we saw in the logically equivalent video. You can actually see that these two statements are logically equivalent because I actually use this as an example. And then also logically equivalent would be the negation for P and Q. So the conjunction P and Q, the negation of that is equivalent to not P or not Q. And again, notice that it kind of is like the distributive property here. We distribute that negation sign, and what that does is it switches the conjunction to a disjunction or the disjunction to a conjunction. And just to verify, since the last video showed the negation of the disjunction, let's look at the negation of the conjunction. So we have P and Q, and we want to negate it, so we put the negation sign there. We're going to show that that is logically equivalent to not P or not Q. I already have this set up and all ready to go. So we have P and Q. Since there's two simple statements, we need 4 rows. And then, as usual, I started with my negations, and then I looked at the compound statements and kind of built them up. So really what we want to show is that whenever this is true, and whenever that's false, the second statement is also false. Filling in my negations, not P is going to have the opposite truth value of P, so that's false, false, true, true. Not Q will have the opposite truth value of Q, so that will be false, true, false, true. P and Q. So in order for P and Q to be true, that means they both have to be true. So jumping over here, we have true and true is true. True and false is false. False and true is false. False and false is false. Now we're looking at the negation of this. So just like we saw the negation of the simple statements, the negation of the negation of the conjunction will have the opposite truth value. So this will be false, true, 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 right? So it's the exact opposite of what we see here. And then lastly, not P or not Q. So this is a disjunction, and for a disjunction to be true, it has to have one or both statements be true. So we're looking at the two negated columns. So we're looking at this column and the column right next to it. We have false or false. That would be false. False or true is true. True or false is true. True or true is true. And so if we compare these two statements, we do see that they are in fact logically equivalent. So De Morgan's law does hold, and we're glad it does. Let's look at some examples. So as always, I encourage you to pause the video and try to write the negation of these 4 statements using De Morgan's law, and then we can talk about them after. Okay, so we want to keep in mind that the negation of an or of a disjunction, P or Q, is equivalent to not P and not Q. And the negation of a conjunction, P and Q, is equivalent to not P or not Q, right? So we kind of like distribute that negation sign. So the first one, I will pass this test, so here's P, or I will drop this class. So the negation of this, we want the negation of P or Q. That would be equivalent to not P, so I will not pass this class, and I do not drop the class. I'm sorry, I do not pass this test. I will not pass this test, and I will not drop the class. That would be the negation, right? Because I will pass this test or I will drop the class. One or the other is going to happen, or maybe both. You pass the test and you're like, this class isn't really for me. Drop. So the negation of that would be you don't pass a test, yet you stay in the class anyway, which happens too, right? Sometimes you're like, well, yeah, I just know I need to study harder next time, or I knew it, but I just, I had a bad day or whatever the case may be. So the negation can happen, right? It can happen. Okay, how about this one? This movie is awesome. Here's P. And it is a comedy, Q. So the negation of the conjunction is the disjunction, not P or not Q. So what does that give us? This movie is not awesome, or it is not a comedy, right? In order for the given statement to hold, the two things must both be true. The movie's awesome and it's a comedy. The negation is just one of those things not being true. So it's not awesome, or it's not a comedy, or maybe neither. I will go to the beach and I will not get sunburned. So we want to be careful here. I go to the beach is P and, but this is actually a negation. This is not Q. So if we look at P and not Q, what would the negation of this look like? Well, that would be not P or, and then not Q is just Q. So it'd be not P or Q. So that would be, I will not go to the beach, or I will get sunburned. I will not go to the beach, or I will get sunburned, right? We have to be careful because this was given as a negation. Sneaky stuff. And the last example, dogs are not cute. So that is a negation. That is not P. And cats are the best, Q. So we want to negate not P and Q. Not P is P. The negation of the conjunction is the disjunction, and the negation of Q is not Q. So dogs are cute, or cats are not the best. These have been examples of applying De Morgan's Law. Thank you for